Okay, Bismillah Rahman Rahim. We are going to start data communication and computer network course. It's called DCN for spring 2020. Okay, and we are going to continue chapter number 3, transport layer from the top down approach computer networking. In the last class, if you do remember, so in the last class we had discussed chapter number 3, RDT 2.1 protocol, its overview, and then we discussed RDT 2.2 protocol. It was negative acknowledgement free, and then we discussed RDT 3.0 and its pipeline protocol. Okay, in today's class we are going to continue chapter number 3. We will continue pipeline protocol and we will finish it. After this we will study TCP segment structure and TCP reliable data transfer protocol. So some field of TCP segment structure will be discussed. So we were discussing go back in approach. It is the pipeline approach. Okay, so we are continuing it. In go back in at the sender side, okay, so when the sender receives the packets, so the data, the sender divides the data into bytes. In each byte or each packet, it is placed in a slot. Okay, so these are the packets that are received from application layer by the sender side, transport layer. Okay, so the transport layer places the packets into these slots, and each slot is given a sequence number. For example, the sequence number is started from 0, 1, 2, 3 up to like this way. Okay, so in go back in we are using k bit sequence number in the packet header. Okay, so when the data is received, so they are assigned sequence number as per the slot. Okay, so suppose we have window up to n. What does it mean? That up to n number of packets they can be sent at a time, unacknowledged. So these are the consecutive unacknowledged packets that are allowed to be sent. Okay, now suppose that in these packets that are received from the transport layer, from the application layer, so among these packets, the green one, these are the packets that are sent and their acknowledgement is received. The green one, it means already acknowledged. So these are the packets that are sent and their acknowledgement is received. What does it mean? That these packets, they are correctly delivered to the receiver. Okay, so the send base, it indicates the first packet, the oldest packet that is sent by the sender, and its acknowledgement is not received. Okay, so the send base, these yellow packets, they indicate that these are sent and not yet acknowledged. What does it mean? That these packets are sent by the sender, but the sender has not received their acknowledgement, so they are in transit. Okay, similarly the blue colors, okay, the blue color, it indicates the packets, okay, they can be sent, because these are the packets that are sent and their acknowledgement is not received. And the next sequence number, okay, it indicates that if the sender wants to transmit the next packet, then this should be the sequence number. This is the next sequence number, indicates that if the sender wants to transmit this next packet, this will be its sequence number. So it is usable and not yet sent. And usable means because the sender has the window size like this, n window size. So among these n window size packets, the yellow packets, they are sent and they are not received. So it means that the green one, they are allowed to send unacknowledged. Okay. So it means that the send base, it indicates the oldest packet that is sent and not received. So send base -1, it will indicate the packets that are sent and that their acknowledgement is received correctly. So, and the next sequence minus send base, it indicates the packets in the range that are sent and that are not acknowledged. And next sequence number indicates that the packet should be sent the next one. Okay. So acknowledgement number, if sender receives acknowledgement number n, if the sender receives acknowledgement number n, so in this go back n we are using cumulative acknowledgement. What does it mean? That all packets including n, they are received correctly. They are received correctly by the receiver. So if the sender receives acknowledgement n, so this acknowledge all packet up to including sequence number n. For example, if the sender receives acknowledgement number 5, so it means that the packets up to sequence number 5, they are received correctly by the receiver. Okay. So a receiver may receive duplicate acknowledgement. We will discuss it. Okay. So we have discussed that in the go back in. So we have discussed that the go back in, it basically it can receives the duplicate acknowledgement. We will discuss it. And as we have discussed in the go back in, that there is single timer. The timer is running for the oldest packet in flight. So which packet is oldest in flight? This send base. This send base, it is the oldest packet that is sent and not acknowledged. So the timer will be running for this packet, not for the rest of the packets. Okay. So there is single timer. And if the timeout happens, for example, if the timeout happens for this packet, if the timeout happens for a packet n, then the sender will transmit this packet and all the subsequent packets that are sent. So if the timeout happens for packet number n, then the sender retransmit packet n and all the packets with the higher sequence number than n, that is n, the packet with the sequence number n, packet with the sequence number n plus 1, n plus 2, all those packets that are sent, all the subsequent packets that are sent, they will be retransmitted. So it will retransmit packet number n and all higher sequence packet in the window. You can see that here, if the timer is expired for this packet, then this packet will be retransmitted, this packet, this packet, this packet, this packet, this packet, this packet. So all the yellow packets, they will be retransmitted. Okay. So you can see that these are the slots that are empty. Why empty? Because these are the having the packets, but they cannot be sent because this is the window size. So these packets can be sent at a time. Okay. So this is the FSM for the go back in approach. It means that the sender is waiting for the packets to be received from the application there. So if it receives the packets, so it check if the next sequence number is less than base plus n. Base plus n means send base plus n. So you can see that this is the send base. It indicates the oldest packet that is sent. And n means the window size, that how many packets can be sent at a time. So if the next sequence number, it is equal to send base plus n, that is mean that all these n number of packets are sent and their acknowledgement is not received. So n number of packets are sent at a time. So you cannot send more than n packets at a time. Okay. But if the next sequence number is less than base plus n, that means that the whole window size is not sent at a time, that n number of packets are not sent, less than n number of packets are sent and their acknowledgement is not received. So it means that we can send more packets, we can send more packets. So the packet is built up and its sequence number is assigned. Okay, and these packets are sent, and if the base is equal to next sequence number, what does it mean? That the whole window is that base is equal to next sequence number, that it means that there is no packet sent. This is the first packet to be transmitted, so this is the oldest packet that will be transmitted, and it's so if this is the oldest packet, this is the first packet to be transmitted. So in this case we have to start the timer, because we start the timer for the oldest packet. Okay, and the next sequence number is incremented. But if the base is not equal to next sequence number, okay, so it means that the timer is already running, so we don't start the timer. So we start the timer only when there is base is equal to next sequence number. What does it mean? That if this is the first packet to be transmitted. Okay, and if the next sequence number is greater than equal to base plus n, what does it mean? It is else. It means that n number of packets are sent and their acknowledgement is not received, so the window size is full. Okay, so we cannot send any more data. Okay, similarly if the timeout happens, so we restart the timer and we send all the packets starting from the base, starting from the send base, we send all the packets till next sequence number, because these are the packets that are sent and their acknowledgement is not received. Okay, so in this case when the timeout happens, start timers and it sends the packet with the base plus 1 up to next sequence minus 1. So you can see that all the packets from send base, second base plus 1 up to next sequence minus 1, so all these yellow packets, they are sent again. Okay, similarly if the packet is received with error, with corrupt, then that packet is sent. Okay, and not corrupt if the acknowledgement is received, it means that acknowledgement received, the data is received correctly. So if the data is received correctly, so what should we do? We should stop the timer of that packet. If base is equal to next sequence number, then timer should be stopped, else we start the timer for the next packet. Okay, so now we are discussing the go back in the receiver side. Okay, so up to now we have discussed the go back in from sender point of view, so how the sender works. Okay, now we are going to discuss the go back in from receiver point of view. So receiver acknowledge only, it means that it always send acknowledgement for correctly received packet with highest n order sequence number. What does it mean? If the receiver receives a packet with sequence number 4 and all the packets are received from the sequence number 1, 2, 3, 4, so it means that packet number 4 is an adder. Okay, so if packet number 4 is an adder, so it will sense acknowledgement number 4. That is mean that packet number 4 is correctly, up to packet number 4 is correctly received. Okay, but if the sender has received the packet up to acknowledgement number 4 and next packet arrives with the acknowledgement number 6, okay, so it will discard. Okay, so acknowledgement only means it always send acknowledgement for correctly received packet with the highest n order sequence. The packet which is received n order, that acknowledgement is sent. So it may generate duplicate acknowledgement, we will discuss it. So need only remember expected sequence number, and out of order packets they are discarded. Okay, they are discarded and the acknowledgement is sent for the highest packet that is received correctly. Okay, so if the receiver has received the packet number 4 correctly up to sequence number 4 correctly, that is packet number 1, 2, 3, 4, they are received correctly, and the receiver receives packet number 6, so packet number 5 is missing, so packet number 6 will be discarded in acknowledgement number 4 will be sent. That is that up to acknowledgement number 4 packet is received. Out of order packet, if they are received, so they are discarded. No receiving buffer is required. And re-acknowledge packet with the highest in order sequence number. That is the packet which is received correctly in order, that oldest acknowledgement will be sent. Okay. So now we are going to so we have discussed go back in, and now we are going to discuss selective repeat. Okay. So selective repeat, in selective repeat we know that the sender can send up to n number unacknowledged packet in pipeline. That is, the sender is allowed to send up to n number of packet at a time. Okay. So if, and second, the receiver sends individual acknowledgement for each packet. So if the receiver receives the packet number 1, so it will send acknowledgement number 1. So acknowledgement number 1 means that only packet number 1 is received correctly. Packet number 0, it is not, it is received or not received. So only if the acknowledgement comes, so this is individual acknowledgement. So it is only acknowledging the individual packet, one packet at a time. Okay. The sender maintains timer for each unacknowledged packet. We have multiple timers, individual timers. So for each packet the timer is running. And then when timer expires, so only retransmit that unacknowledged packet. Other packets are not retransmitted. Okay. So selective repeat, the receivers have individual, the receiver individually acknowledge all correctly received packets. So it means that buffer packets. Why buffer packets? If out of order packets are received, so they are stored and they are acknowledged. In the go back in, out of order packets are not stored, they are discarded. But here the out of order packets, they are stored. So we need buffer at the receiver. Buffer packets is needed for eventually another delivery to upper layer. Sender only resends packet for which acknowledgement is not received. So if the timer is expired, then the sender only resends the packet for which acknowledgement is not received, for which the timer is expired. So the sender timer for each unacknowledged packet. And sender window size, sender can send up to n consecutive sequence number packets at a time. So it limits the sequence number of sent unacknowledged packets. So it means that in the go back and select repeat, both have n window size, that n number of packets they can be sent at a time. Okay. So its working is like this way. For example, this is the sender side. So the send base means that the oldest packet that is sent and not acknowledged. And next sequence number means, so this yellow, it indicates the packet that are sent and that are not acknowledged. And the green one, they indicate that the packet are sent and they are not acknowledged yet. The green one, it means that these are the packets that are sent and they are acknowledged. So they are correctly received by the receiver. And the yellow means that these are the packets that are sent and that are not acknowledged yet. And the send base means the oldest packet that is sent and not acknowledged. And next sequence number, if the sender is want to send next packet, then sequence number should be next sequence number. This is the receiver. So receiver are receiving the packet. So you can see that receiver has received out of order packet. So this packet is received out of order. Why? Because this packet is missing. This packet is missing. So receiver received this packet, so it is stored here. It is stored here. And this packet is missing, it is received, so it is stored and it is acknowledged. When the out of order packet is received, they are stored and they are acknowledged. So because we have individual acknowledgement, so only acknowledgement for this packet is sent. Okay, when this packet is received, okay, then it means that the sequence number is up to this, they are received in order. Okay, so these three n order packets will be delivered to the application layer. And since this packet is missing and these two packets are received, so these two packets will not be delivered to the application. Why? Because to the application, the selective repeats gives the packet in order. So because these two packets, they are not in order. Why? Because this packet is missing. When this packet is received, then they will become in order. Okay, so the packet, the selective repeat stores the out of order packets and acknowledge out of order packets, but they are not delivered to the application layer. They are delivered to the application once all the packets they are in sequence. They are received in sequence. Okay. So in the selective repeat, from the sender point of view, when the sender receives the data from above, that is from application layer, if next available sequence in window, that is if less than n number of packets are sent and they are not acknowledged, so it means that the sender can send next packet, so it will send the next packet. If the time is out, then for packet number n, for packet number 5, so only resend packet number n, that is packet number 5 is only resent, and the timer is again restarted for packet number 5 because we have individual timer. And if acknowledgement is received, acknowledgement number n, so it means that only packet number n is acknowledged, so only the timer for packet number n is stopped, only packet number n is marked as received, mark packet n as received. Okay, mark as packet number n as received means that its color will be green, its color will be green. Okay, and if n is smallest, n is smallest means that if n is the oldest packet that is sent and unacknowledged, then the send base will be forwarded. Okay, so if n smallest unacknowledged packets, advance window base to the next unacknowledged sequence, so this window base, that is the send base, it will be advanced. Okay, so if we receive the acknowledgement for these two packets, then the send base will becomes this one. If we receive the acknowledgement for this packet, then the send base will become for this packet, because this will become the next packet, that oldest one. Okay, so similarly at the receiver end, when the receiver receives packet number n, so it sends packet acknowledgement number n, that is only packet number n is received. If for example, if the receiver receives packet number 5, so the sender will send acknowledgement number 5, that is only packet number 5 is received correctly. If this packet is out of order, then it will be stored in buffer, it will be stored in buffer. And in order, if they are in order, then it is delivered to the application, and advance the window to the next yet received packet. Okay, for example, you can see here, this is the receive base, this is the first sequence number that the receiver is expecting, this is the sequence number, smallest sequence number that the receiver is expecting from the sender. So these higher sequence number packets, they are received, they are stored out of order, this pink color. Okay, they are received, they are out of order, but they are stored, but the receive base is here. Okay, and these pink color packets, they will not be delivered to the application. Why? Because they are out of order, because here this one is missing and this one is missing. Okay, when this packet is received, then these three become in order, so these three will be given to the application, and this receive base, it will be advanced to this one. Now it will be expecting for this packet to be received. Okay, so if the packet is received in order, then advance window size to the next not yet received packet. Similarly, if the packet n is received, okay, then it sends the acknowledgement number n. If it is in order, then it sends the acknowledgement number n. If otherwise, it ignores. Okay, if the packet is duplicate, then it ignores. Okay, now let's discuss the selective repeat approach through an example. Okay, so you can see that, suppose here that the sender window is n is equal to 4. What does it mean? That the sender is allowed to send 4 packets at a time unacknowledged. Suppose that from the application layer, the sender receives 9 packets. So they are assigned packet sequence number 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so since the window size in n is equal to 4, it means that among these n number of 9 number of packets, the sender can send 4 packets at a time. So these 4 packets, the first 4 packets, they will be sent. So packet number 0, 1, 2, 3. So the packet with the sequence number 0, 1, 2, 3, they are sent. Okay, 4 packet cannot be sent. Packet with the sequence number 4. Why? Because the window size is equal to 4. So it means that 4 packets can be sent at a time. And you can see that for each packet, timeout is started. The timer is started. For packet number 0, for packet number 1, for packet number 2, for packet number 3. Okay, so suppose packet number 0 is received correctly. So the receiver is expecting packet number 0 and it is received. So it will send acknowledgement number 0 and it will deliver this data to application layer. Okay, so when acknowledgement number 0 is received, so its timer will be stopped. You can see that its timer will stop. And the send base, it was pointing to packet number 0. Now the send base will point to packet number 1. Okay. Now when the acknowledgement number 0 is received, so it means that packet number 0 is delivered correctly. So now packet number 1, 2, 3, they are unacknowledged. 3 packets are unacknowledged. And the window size is n equal to 4. So it means that one more packet can be sent by the sender. So sender sends next packet with the sequence number 4, packet number 4. Okay, suppose packet number 1, the second number packet with sequence number 1, it is received correctly. So it is also in order. So it will be delivered to the application. Okay, it is in order. Packet number 0 and 1, they are in order. So and acknowledgement number 1 will be sent. Okay, when acknowledgement number 1 is received, okay, so this when acknowledgement number 1 is received, so the timer for packet number 1 will be stopped. You can see that the timer for packet number 1 will be stopped. Okay, so now you can see that packet number 2, 3 and 4, they are sent and they are not, their acknowledgement is not received yet. So these packets are in flight. So 3 number of packets are in flight, and the window size n is equal to 4. That at a time 4 packets can be in flight. 4 packets can be sent at a time. So the sender can send one more packet. That is packet number 5 will be sent. Okay. Now suppose that packet number 2 is lost. Okay, and packet number 3 is received. So packet number 3, it is received out of order. So it will not be delivered to the application. It will be stored and buffer. It will be stored and buffer, and the acknowledgement will be sent for packet number 3. So the acknowledgement will be acknowledgement number 3. Acknowledgement number 3 means that the packet number 3 is received correctly. So acknowledgement number 3 is received, arrived correctly. So its timer will be stopped. Packet number 3 timer will be stopped. Okay. So you can see that the packet number 3, its timer is stopped. Okay. So the send base is not advanced. Why? The send base is pointing to this packet number 2. Okay. Now suppose that the packet number 4, it is also received, and this packet number 4, it is received out of order. Why? Because the receiver is expecting packet number 2. Packet number 0, 1 are received and 2 is not received. Okay, so this packet number 4 is out of order, so it will be stored and buffer, and its acknowledgement will be sent. Acknowledgement number will be 4, so acknowledgement number 4 is sent. When acknowledgement number 4 is arrived, so its timer will be stopped. Its timer will be stopped. It is received correctly. Okay, so similarly the packet number 5, it is received correctly. It is also out of order. Why? Because the receiver is waiting for packet number 2, for packet number 2. So it will resense the packet, so it will also buffer the packet number 5. Okay, the packet number 5 will be buffered. Okay, so packet 5 is received, it is also out of order, so it will be buffered and its acknowledgement will be sent. Okay, now suppose that the timer of packet number 2, it is expired. Okay, so you can see that it's the when the acknowledgement number 5 is arrived, so its timeout will be also cancelled, it will be cancelled. So you can see that the packet number 2, its timer is running, and suppose its timeout expires. Okay, so when the timeout for packet 2 happens, so the packet 2 will be resent. When the packet number 2 is received, so it means that it will be stored here, another. So it means that packet number 2, packet number 3, 4, 5, packet number 3, 4, 5, they are already received, but they are not delivered to the application. Why? Because they were out of order. And when packet number 2 is received, so it means that packet number 2, 3, 4, 5, they becomes another. Okay, so when they becomes another, so all these 3 packets, 4 packets, they will be given to the application, and acknowledgement will be sent for 2. Why? Because packet number 2 is received correctly, so acknowledgement number 2 will be arrived. Okay, so when the acknowledgement number 2 arrives, so its timer will be stopped. Okay, and its timer will be stopped, and the send base will be advanced. The send base will be advanced because it will now point to the packet number 6. Packet number 6. Okay. Now let's discuss selective repeat, a problem. There is a problem in selective repeat, and we will discuss it. What is the problem? Suppose that we have sequence number 0, 1, 2, 3, and the window size is 3. That is, if we received 5 packets, then the first packet will have sequence number 0, second will have sequence number 1, third will have sequence number 2, fourth will have sequence number 3, fifth will have again sequence number 0. Okay, so you can see that here there are how many packets? 1, 2, 3, 4, 5, 6, 7. So the first packet has sequence number 0, second 1, third 2, fourth 3, fifth packet will have sequence number 0, sixth will have 1 again. So the sequence number again restarts. Okay. Window size 3 means that 3 packets can be sent at a time, unacknowledged. So suppose the sender has 7 packets, but these 7 packets cannot be sent at a time. Only 3 packets can be sent. So suppose packet number 0, 1, 2, they are sent. Okay, so similarly the receiving when is expecting for packet number 0, and when packet number 0 is received, so it is in order, it will be delivered to the application, and it will send acknowledgement number 1, acknowledgement number 0 for this packet. So when the receiver receives packet number 0 correctly, it is delivered to the application. So the receiver will advance its receive base. Okay, it will advance its receive base point to the 1. That now the receiver is expecting packet with the sequence number 1. The second packet with the sequence number 1. Okay. Similarly, when the sender receives acknowledgement number 0, so it will advance the send base, that now this is the oldest packet, 1 packet with the sequence number 1. It is the oldest packet that is sent and not acknowledged, and so it has sent 3 packets, 0, 1, 2. So 1, 2, when the acknowledgement number 0 is received, so it means that it can send the next packet. So packet number 3 is sent. Okay, so this is the window n, because window n means that n number of 3 number of packets can be sent at a time. So when 0, 1, 2 are sent, and the packet for 0 packet 0, the acknowledgement is received, so 1, 2 will be remain in flight. So fourth number packet with the sequence number 3 can be sent. Okay. Now suppose the acknowledgement packet number 1 is arrived correctly. Okay, so this is an adder, it will be delivered to the application layer. And now the receiver will advance its receive base to 2. That is, the receiver is now expecting the third packet with the sequence number 2. Okay, similarly it will sense the acknowledgement. So when acknowledgement is received, so it will also advance that packet number 1 is received correctly. So now the sender has sent packet number 2 oldest, that is unacknowledged. Okay, so 2 and 3 are sent, so window size is equal to 3, so the sender can send the fifth packet, that is with the sequence number 0. Okay, now suppose that the packet number 3 is lost. Packet number 3 is suppose packet number 2 is received, so it is received, it is in order, it will be delivered to the application, and this receiver will advance its receive base to 3. That is, now the receiver is waiting for the fourth packet with the sequence number 3. Okay, so the receiver is waiting for the fourth packet with the sequence number 3, and the fifth packet with the sequence number 0, and the sixth packet with the sequence number 1. Okay, and when acknowledgement 2 is received, okay, acknowledgement 2 is received, so it means that 2 is also acknowledged. Okay, now suppose what happens that at this time the packet 3 is lost. Packet 3 is lost, and the packet number 0 is received correctly. Packet number 0, it is received correctly, it is received. So this packet 0, it is the fifth packet. 1 2 3 4, it is the fifth packet. So it is the fifth packet, and it will be placed here in the fifth packet location. Okay, so there is no problem, it's okay. But let's discuss this same phenomena through another perspective. Suppose the sender sends 3 packets, packet number 0 1 2. They are received, packet number 0 is received, so it is delivered to the application layer, and its acknowledgement is sent. Suppose this acknowledgement is lost. So the receiver has received packet number 0, its acknowledgement is sent, so it will advance its receive base. That now the receiver is expecting the next packet number 2 with the sequence 1, and packet number 3 with the sequence number 2, and packet 4th with the sequence number 3. Okay, so it advances its pointer. Suppose that the receiver receives packet number 1, second packet, so it is in order, it will be delivered to the application, and it will advance its receive base. That now the receiver is waiting for the third packet with the sequence number 2, and fourth packet with the sequence number 3, and fifth packet with the sequence number 0. Suppose the receiver receives packet number 2 correctly. So packet with the sequence number 2, it is received correctly, it is in order, it will be delivered to the application, and it will advance, the receiver will advance its receive base. That now it is pointing to the fourth packet with the sequence number 3, and the fifth packet with the sequence number 0, and the sixth packet with the sequence number 1. Suppose these acknowledgements are lost. When these acknowledgements are lost, and suppose its packet number 0 timer is expired, so packet number 0 is retransmitted. So packet number 0 has the sequence number 0. When it is arrived, it will be considered from the receiver point of view that this is the fifth packet, so it will be placed here. Although it is not fifth packet, it is the first packet, it is retransmitted, its acknowledgement is lost. Its acknowledgement is lost. So here the figure A and figure B. Here figure A is correct, it is no problem, but here figure B, it is wrong, because packet 0 is not the fifth packet. Packet 0 is the first packet, it's retransmitted. Packet 0 acknowledgement is lost. So this problem happens. This is a problem. Okay, so this is a problem. Okay, So the receiver sees no difference in two scenario. Here in figure A and figure B, they are same. But figure A in figure A it is correct, but in figure B it is not correct. So the receiver window, it is not available, it is not visible to the sender. So the receiver side, it is not visible to the sender. So the duplicate data is accepted as new one. In figure number B, this packet number 0, it is duplicate, but it is accepted as a packet number 5th as a new packet. Here the packet 0, it is expected as a new packet, and it is also it is the new packet, it is the 5th packet, it is correct. But here it is not the 5th packet, it is the first packet, it is retransmitted. The packet number 0 is retransmitted, but the receiver considered it as a first packet. Okay, so why this problem happens? This problem happens due to that the sequence number is the sequence number, it should be greater, the sequence number size, it should be greater than the window size. So what relationship between sequence number size and window size to avoid this problem? This is called wrap around problem. So the window size, it should be half of the sequence size, then this problem will not happen. It means that the window size and the sequence number size, the sequence number size should be double than the window size. If the window size is 4, then the sequence size it should be 8. If the window size is 8, then the sequence size should be 16. Then this problem will not happen. So this problem why happens? This problem happens because the sequence number wrap around. The sequence number restart again early. It start early. So the sequence size and the window size, they are close. That is why this problem happens. Okay. So if the window size is half or less than half that of sequence size, then this problem will not happen. Okay. So this is the so we have discussed this thing. Okay.